we finished graphing quadratics with transformations, but this leads right into solving quadratics because our first strategy is going to be graph them and find the x-intercepts. So just big ideas, we've looked at graphing quadratic functions and how the graphs can be used to model real-life situations. Some of the real-life situations we will continue to look at include maximizing profit or surface or area, and the movement of objects through space. We will learn how to solve quadratic equations using algebra and how to pick the best strategy to solve a quadratic equation. So there's going to be 5 different strategies. So you're going to have a whole toolbox of how to solve quadratic equations, and then you'll want to pick the best strategy for the situation, whether it's factoring, the quadratic formula, completing the square, taking square roots. And even within factoring, there's going to be 4 different strategies within factoring. So you're going to have a really full toolbox, but you're doing the same thing every time. You're solving a quadratic equation. And then we're going to see for a couple days during your virtual unit that some quadratic equations do not have any solutions. So we will see how to expand the real number system in such a way that we could still have solutions. It's the complex number system, imaginary numbers. Just a couple days on that, so when you're solving, you've seen them before, especially if you're going on to pre-calculus or if you see it on the SAT, you'll have seen complex numbers. So we've got kind of 3 days before we leave each other and then an additional, virtual week. So next week, you actually have Wednesday off for Veterans Day, so there's no assignment that day. If you keep going down to the 20th, that's the Friday before Thanksgiving week, it's a remote learning day for all students, so you'll still have this virtual lesson to do, and we may end up meeting live for that half hour if you have questions. I don't know what exactly the remote learning day entails yet. And then the 2 days, Monday, Tuesday down here are still virtual going into Thanksgiving week. So Monday and Tuesday of Thanksgiving week, you're still doing your virtual assignments, but at school. And then you have Wednesday, Thursday, Friday off. So I wrote down here, see you Monday the 30th. So I wanted to start with just the big ideas of this unit. It's kind of nice that we get these few days together so that I can show you how to factor in person if you've never seen factoring before. But we're kind of doing them in order. So solving by graphing, we're doing first because you already know how to graph. So the big idea of this unit is to find solutions to quadratic equations. It's important to remember that all real solutions are just x-intercepts on the graph. And solving a quadratic just means the x value that makes the equation equal 0. So whether a question asks you to find the solutions, the root of the quadratic, the 0, like on your calculator, second calculate 0, the x-intercept, those are all referring to the same thing. So whether they ask you for one of these 4 words, they're all interchangeable synonyms of each other. Here are the strategies I was talking about. So these 5 strategies, we're going to do graphing and factoring before you go virtual, and then you'll look at these 3 strategies while you're virtual with videos. So we're going to dive in and do quadratics by graphing first. So this front page, I've already graphed it for you. So if the function is y equals x squared minus x minus 2, I graphed it for you on the calculator. What are the x-intercepts of this graph? Well, one of them is at -1, and one of them is at 2. So I write x-intercepts, -1, 0, +2, 0. That's if I was finding x-intercepts from a function. But they asked me in slightly a different way, what if I had this same equation, but now I said equals 0, and you had to find the solutions to this equation? Well, if you had a calculator, the 2 x-intercepts are the 2 solutions. X equals -1 or +2. So you write solutions in slightly a different way than you write x-intercepts. X-intercepts are coordinates on the graph. There we go. Is that a little better? So sometimes you'll see a quadratic that only has one x-intercept. So this function, when I graphed it, only touch the axis at that one point. So it only has an x-intercept at 5, 0. So its only solution is when x equals 5. If I plug 5 into this equation, 5 squared is 25, minus 10 times 5, so minus 50 plus 25, that gives me 0. So it's the x value that when you plug it in, you get 0. The next function happens to be a concave down parabola. Hopefully on your performance task, your a value was negative because it had to be concave down. So it has x-intercepts at 1 and 3. So 1, 0 and 3, 0, which means when I plug in those numbers in my equation, I get 0 as an output. So x is 1 or 3 are my solutions. Oh, why it's so great. Okay, and then this last one, there's no x-intercepts. So there are none. And so there's no solution to this quadratic equation. So what I was talking about is when we go virtual, when we talk about complex numbers, there actually are complex roots dealing with I, but there's no real numbers. There's no x-intercepts. So it's okay to only have one x-intercept, and it's okay to have no x-intercepts. That's an appropriate answer. So here's just an application problem, kind of like what we've already done. It was kind of tying the units together last year, so I just left it in. So this is if you hadn't seen projectile motion before, but just that a ball is thrown straight up from 3 meters above the ground. That's its starting height. It has a velocity of 14 meters per second. When will it hit the ground? So ignoring air resistance, we can work out the height by adding up these three things, dealing with gravity. So they've created the equation for you. So to find where the ball hits the ground, we're solving this quadratic equation. Negative 5t squared plus 14t plus 3 equals 0. So for the enthusiast, there's your negative 9.8 or 9.8 meters per second squared. We've already talked about that this year in more depth. So if I look at a graph of this equation, here's my graph, right? Here's that starting point at 0, 3. When does it hit the ground? At 3 seconds. So on the test last week, a lot of you had trouble on interpreting the graphs. I think you're much stronger at it now if you retook your test from last week. But we're going to learn strategies to be able to solve this algebraically. So most of the time, you don't need to look at the graph to find the x-intercepts. You're going to factor it, use the quadratic formula. A lot of times, the graph is going to cut through somewhere between two of your integers. It's not going to be exactly at 3. So you want to be able to find the exact x-intercept. So I wanted to do a few of these with you and then have you finish 301 in class. I guess we'll probably have time to get it finished actually today. So let's just do a quick review of how to graph quadratic equations, right? Because some of these are in standard form, intercept form, and vertex form. So I know it was a whole week ago, but you still need to know how to graph them in this unit. So number 1 and 2 are really just vertex form, right? Shift them up, down, left, or right. Can someone tell me what the key points of a quadratic graph are again? What are the key points of a quadratic? Well, the vertex is 0, 0. And what are the other key points on a quadratic? Yeah. So on graph number 2, what does this a value do? Cuts all the y values in half, right? So 0, 0, 1, 1/2, 2, 2, 3, 4.5. So just tell me what transformation has occurred on number 1? It's gone where? Down 4. And what transformation has occurred on number 2? The opposite. It's gone right 1. So your work, kind of for these next 15 minutes, because I think you'll be able to finish it before you leave, is to get these like 8 graphs and questions answered, and I'll come around and make sure that you don't have questions on that.